Geometric sequences. We were working with arithmetic sequences, and now we're moving on to geometric. And I'm going to start with this story problem over here because we've all seen something like that come across our email. Julian sees a new band at a concert. He shares the band's website with 5 of his friends and says, "If you don't share this with 5 of your friends, you will die before midnight." Assuming everyone does as commanded, how many people receive the message by the 8th round? So we could kind of sketch this out. Here's Julian. How many people did he share it with? 5. 1, 2, 3, 4, 5. Little person at the end of every one of those. All right, and how many people are they supposed to share it with? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, people at the end of all of these now. And then from each one of those, we need 5 more. And you can see that we're only on round 3, and it's getting really cumbersome. And so formulas always make things friendlier than doing them by rote when our numbers get huge. So you'll see over here, we have our formula. And let's remember what a geometric sequence is. And it is a predictable pattern based on a common ratio. All right, let's figure out what all of these mean. There we go. A sub n is the value at any term. Meaning, if I told you the 8th spot equals 257, the 8th spot is 257, A sub n is 257. If our 14th spot is 1058, then A sub n is 1058, okay? A sub 1, first term. R here is our rate of growth. And n is any real number. And it is any term, right? Any term. So let's come back over and let's look at this story problem again. Let's not try to map it out. Let's see if we can use the formula. Okay, it wants to know how many people after the 8th round, right? 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. So we want to know how many people in the 8th round, how many people were after his first initial email. He'd send it to 5. And then how many people are they supposed to send it to? 5 and n minus 1. So that would be 8 minus 1. Value at the 8th term, 5. 5 raised to the 7th power. And you'll find that these will get quite huge quickly. How many people after the 8th round? 390,625. Wow. Right? Glad we didn't map that out and then have to count them individually. Okay, a couple more problems in here. Find the 11th term of a geometric sequence. All right, and it tells me the first term and it tells me the rate. I want to know the value of the 11th term. 12 is the first term. My rate is 3. N is 11. Formula says take away 1. 12 times 3 to the 10th, and we get 708,588. Again, those get large quickly. Write an equation for the nth term of the geometric sequence. All right, this just wants a formula, which we can do. For the nth term, a sub n equals, the first term is 33 times the rate. Okay, here I don't know the rate. It's not given to me, so I've got to calculate it. What do I multiply to get from 33 to negative 99? Negative 3. Let's check. Times this by negative 3. Do I get to 297? Yep. So my rate is negative 3. Raised to the n minus 1. That's simplified. That's as small as it gets. So there's your intro to geometric sequences.